Hello everyone, here is a question based on de Broglie wavelength. In hydrogen atom, the de Broglie wavelength of an electron in the second Bohr orbit is how much? Bohr radius is given in picometers. We know that Bohr radius for nth orbit is equal to 52.9 picometer times n square divided by z. N is the value of the orbit and z is the atomic number. For hydrogen atom, z value is equal to 1. Here it is mentioned as second Bohr orbit and therefore n value is equal to 2 here. Therefore, R2 will be equal to A0 is given as 52.9 picometer. Therefore, this is A0 times 2 square. That means R2 will be 4 times A0. We know that de Broglie wavelength lambda is equal to Planck constant h divided by mv. Now, we also know from Bohr's theory that electrons can revolve only in those orbits where the angular momentum mvr must be equal to an integral multiple of h divided by 2 pi. From these two equations, we can write that 2 pi r is equal to n times h divided by mv and that is equal to n times lambda. What this equation 2 pi r equal to n lambda means is that the circumference of the orbit must be an integral multiple of the wavelength of the electron wave, and therefore let us substitute r2 here. If we do that, then 2 pi 4 times A0 is equal to 2 times lambda. We can cancel 2 on both sides. 4 times 50 is 200 and 4 times 2.9 will be equal to 11.6 and therefore this will be 211.6, but we do have a pi here and this means that option B is correct. 211.6 pi picometer should be the correct answer.